Hello dear students, today we will try to understand the final topic on interference, that is the Newton's ring. So Newton's ring is a particular experimental arrangement where we have interference by division of amplitude, and also this is the mechanism of formation of fringes in the thin films. One should also understand that here the fringes, these are the fringes of equal thickness, that is the fugous fringes, and definitely as the name suggests, the ring. So why the fringes are circular in nature? So that is everything what we will try to understand in this particular class. So the experimental arrangement, let me first draw the experimental arrangement of the Newton's ring experiment. So it is something of this particular nature. So first of all, it's the experimental arrangement, then I will go for the theory of it, such that you have a proper understanding. So this topic is extremely important for your upcoming examination. So from that point of view, try to have a clear explanation, clear understanding of this particular topic. So this is a plain some glass plate type of arrangements. If you have done the experiment properly in your classroom, in your colleges, so you are quite familiar with this setup. Now over this one we have a plano-convex lens. So there is a plano-convex lens over here. So let us try to have a look of that plano-convex lens. এখানটাতে একটা plano-convex lens আছে। Okay, more or less I have been able to draw. It could have been fine if I could draw it at the mid position. এটা মাঝখানে draw করতে হবে, হ্যাঁ, you have to draw it at the mid position, right? And these are the, this is the medium. Okay, so these shades actually indicates that the space in between, এই যে এখানে মাঝখানে যে স্পেসটা আছে, so the space in between is some other medium. Okay, so this medium is definitely for general experiment, it is just the air medium, and the top and the bottom medium are the glass medium. So এখানে top bottom এর যে মিডিয়ামটা আছে সেটা definitely glass medium আছে এখানে, so that is the glass medium over here. So the diagram would have been perfect if this could have been drawn at just the 50%, just the half of the plate. You see that it appears some 60-40 type of arrangement, so please try to avoid it, and at the time of exam please try to use your compass, scale, pencil, everything for your proper diagrammatic approach. So proper diagramমের জন্য scale, pencil এগুলো ইউজ করবে such that the things looks fine and proper. So I have tried to draw it more or less in my own way, so it's not quite perfect, so you just follow your textbooks for a perfect diagram also. Now let me show the ray diagram over here. So the ray diagrammatic approach over here, so that is what I would like to know next. So this is about you see that the ray diagram, if I want to show it, let me choose a color properly. So suppose this is the incident ray. In this case এটা হচ্ছে incident ray টা আমাদের, this is my incident ray, and then the incident ray, you understand that at this particular point, so this will be reflected somewhere like this, so এটা reflected হবে and there will be another reflection over here, so আবার একটা reflection হবে, so like this, that is transmission. So one of the reflection and transmission, so that would occur over here, and finally there will be some transmission in this way, and then there will be reflections finally. So there will be some multiple reflections over here which we don't show in very details, so বেশি details এ দেখানো হচ্ছে না, more or less I just try to show you the arrangement. So মোটামুটি আমরা arrangementটা দেখানোর চেষ্টা করলাম এখানেতে. So what I want to say basically is that I have two rays of light over here. So আমার কাছে দুটো ray of light আছে, there are two interfering beams over here, so that is what is interesting to know, that I have two interfering beams. So আমাদের কাছে দুটো interfering beam এখানে আছে, so যেটা আমরা দেখতে পাচ্ছি, there are two interfering beams over here, and these are the two interfering beams. Okay, so this one is my, suppose the ray R1, and this one is my ray R2, and you can convert them accordingly as per your requirement, and then you can obtain the interference fringes under that particular case. So this is the center, that is O, although it doesn't appear, but still you have to consider it to be the center. This particular point I just color it magenta, so this one is my N, and this particular point I call it G, because these are the points of reflections and all other points are points of transmission. So you দেখবে যে N আর G এই দুটো পয়েন্টে দেখো রিফ্লেকশন হচ্ছে, there is reflection only at the point N and next reflection at the point G, and we are interested in this because we need to check that if there is any extra phase difference or something like that due to the reflection from the medium where it is backed by the denser medium, that is when light travels from rarer to denser medium. And in this case you will see that there is a such abrupt phase change of pi that will occur at the point G. Point G te দেখো একটা abrupt phase change আছে, that is at the point G, because the reflection in this case, this is somehow different from the other film experiments, that is the parallel films or the wedge shaped film. This is somehow different. You see, you look at this particular light, এখানটাতে এই লাইটটাতে দেখো তুমি, you look at this particular light over here, that you will find it that this reflection, এখানে যে রিফ্লেকশনটা হচ্ছে, the reflection that actually occurs over here, এখানে যে রিফ্লেকশনটা হচ্ছে, so this is backed by what type of medium? So in the bottom what medium do you have? So নিচে কোন মিডিয়াম আছে এখানেতে? So definitely this was a glass medium. So this is a glass plate and this is a plano convex lens, both are made up of same material, that is the glass medium, and these blue dots are actually the ear medium in this particular case. Initially these are definitely the প্রথমে যেটা সেটা এই ডটেড লাইন্স গুলো কিন্তু তোমাদের এখানটাতে these are ear medium. So definitely as the light is entering this black line, this one, so this actually travels. You just look from this point to this point, এই পয়েন্টে যদি কনসেন্ট্রেট করো, if you just concentrate on this point, you see that the light travels from the glass medium towards the ear medium, that is at the point N. So at the point N it is backed, মানে নিচে, backed by what? So what it is having? So it is having a rarer medium. So the light is traveling from the denser, that is the glass medium, to this medium, to this ear medium. So that is from denser to rarer medium. It is traveling from the denser to the rarer medium. And what happens as it travels from the denser to the rarer medium is that, so there is no abrupt phase change in R1. So R1 এ কোনো abrupt phase change নেই. But the same ray, that is from N to G, you just concentrate from N to G. From N to G, it is traveling from the rarer to the denser medium, because this is the denser medium. It is the denser medium. So G is backed by denser medium. So at this particular reflection, that is the ray R2, so the R2 will have an extra phase of pi, that is due to the reflection from the denser medium. Okay, so this is the so this is the case that you are going to have in this particular arrangement. So let me write something about this one for your convenience, such that you can read it directly. So বই থেকে সরাসরি পড়তে পারবে। দু একটা কাজের কথা এখানে লিখে দিই আমি। Newton's ring is an experimental arrangement. Newton's ring is an experimental arrangement. Newton's ring is an experimental arrangement to obtain interference fringes. To obtain interference fringes. Newton's ring is an experimental arrangement to obtain interference fringes by thin film. Interference fringes by thin film. Newton's rings are obtained Newton's rings are obtained by placing a plano convex lens, by placing a plano convex lens over a glass plate, thus forming a thin film, monotonically increasing in thickness, monotonically increasing in thickness, monotonically মানে একচেটিয়া, মানে only it is increasing, forming a thin film which is only increasing in thickness from the point of contact O, from the point of contact capital O, right? So this is the arrangement. If it is illuminated by a monochromatic source of light, if it is illuminated with a monochromatic, if it is illuminated with a monochromatic if it is illuminated with a monochromatic source of light, if it is illuminated with a monochromatic source of light, comma, concentric rings are obtained as interference fringes. Concentric rings are obtained as interference fringes. Concentric rings are obtained as interference fringes. Newton first measured the diameter of the rings. First measured the diameter of the rings and hence the name. So this is all about the introduction of this particular experimental arrangement. So you see that there are two reflected rays that I obtain over here, and these blue dots actually signify that there is a thin film in between the glass plate and the plano-convex lens. So plano-convex lens or glass plate এর মাঝখানে এই যে ডটেড যেগুলো দেখতে পাচ্ছ, whatever dotted you find, so these are actually over here, this is a thin film, and this thin film is neither wedge shaped nor it is parallel. So far you have studied two types of thin film. One is the parallel, which correspond to the Heidinger fringes, circular in nature, and then you corresponded to the wedge shaped film. These are the fringes of equal thickness, but there were straight line fringes. I have drawn the diagram on my last class where you have seen that some straight lines were formed on top of this surface. So there were alternate bright and the dark bands over there. So alternate dark and bright bands in the straight form. Straight fringes were formed due to the wedge nature. So these were known as the physio fringes or the fringes of equal thickness. Right? Why do I call it fringes of equal thickness? Because a particular this particular fringe is generated due to a particular thickness, and the next fringe is again having a particular thickness, and the next fringe is again having a particular thickness. That is, this thickness is actually responsible for a particular fringe over here, and here also a particular thickness from the point O as you move outward on either, not either side, on all sides basically, because this arrangement is something like on a tabletop you put a utensil, for the cooking utensil, মানে যেটাকে আমরা which one you call excuse me, so on a tabletop you put a karai, so আমরা কড়াই যেটাকে বলি, so কড়াই or you call it karai, so that one you just put it over a table, so just the idea is to cook something over it. So সেটাতে কিছু একটা রান্না করতে গেলে একটা কড়াই, you put a karai over your that tabletop, and that is what is generated over here also. So this plano-convex lens actually plays the role of that karai, and you see that the thin film will be formed at the 2 pi angle all around the point of contact. So point of contact এ গোটা 2 pi তেই কিন্তু এটা থাকবে, right? And that is why the fringes over here will be what? That is, it will be circular in nature. And when you look it from the top surface, যখন উপর থেকে দেখবে, so when you will look it, so you should look in this direction. So when you look it, these circles will appear over here. So previously in the physio fringes, that is the fringes of equal thickness, those are straight line in nature due to the nature of the wedge. So এটা wedge এর জন্য ছিল, মানে একটা this particular fringe was due to a thickness T. This particular fringe was due to a thickness T dash. Here also the different circles, the circles that you find over here, the circles, the fringe circles are due to the different radius. That is, if you consider the point N, so you see that at the point N there is a particular thickness. If you consider this particular point, so then there is again a thickness. So that is how the things are going on over here. If you go to this point, so then that one is having some other thickness. So this thickness will generate this particular circle. এই সার্কেলটা জেনারেট করবে, this thickness will generate this particular circle. Okay, so that is how the shape of the fringes are circular in nature in this particular experiment. I hope that I have been able to make you understand about the different type of fringes that are possible in this experiment. So you remember that although these are the physio fringes, but still it is circular in nature. Many students have confusion that circular fringe means it is the Heidinger fringes. No, Heidinger fringes means it is the not circular. Circle is not important. Important is the fringe, a particular fringe is generated due to the same angle of inclination of the incident ray. And in the fringes of equal thickness, a fringe is generated due to a particular thickness of the film, which is the case over here. And here the geometry is circular, it is not wedge shaped. For wedge shaped it was plain, it was the straight line fringes, but here you see the geometry is itself circular. That is on a tabletop you have a karai, and around the karai you know that it is a circular type in nature. So that is what is going on, and these two rays will now reflect and it will give you the fringe system. In actual experiment we use normal rays. Actual experiment আমরা এরকম ray নিই না, in the actual experiment we take the normal rays over here. Actual experiment আমরা normal rays নিই for the different types of simplicity. মানে the data that you have used in your experiment, the experiment that you have done, so those are all for the normal incidence. I will draw that experimental arrangement also. So arrangement, no, I don't have that arrangement with me, so that is actually not necessary in the theory classes. You may go through this. So তুমি দেখবে যে there is a plate like this, on a glass plate. If you go through the practical books or the theory books also, some light from the source is made to incident like this, এরকম ভাবে লাইটটা এসে পড়ে, and these lights are incident on what? So these are incident on this particular arrangement, এবং এখানে এসে লাইটটা পড়ে. Okay, so this is the arrangement that you have. So this light for a particular thickness, this light is incident at some other thickness, so there is some other light also which is incident at some other thickness, and that is why the different thicknesses that you obtain at the different points. Okay, so that's the practical arrangement. So you just go through a book for the arrangement. So now I will go for the theory of it. So here we start our discussion, that is the theory. So in the theory I will just make out the points, the explanation of the formation of fringes, the explanation of the formation of the fringes, explanation of the formation of the fringes is discussed on the basis of interference in thin films, on the basis of interference in thin film. Okay, in this figure we show two reflected rays. In this figure we show two reflected rays. In this figure we show two reflected rays, R1 and R2. We show two reflected rays, R1 and R2. We show two reflected rays, R1 and R2, where a phase change of pi, where a phase change of pi where a sudden phase change of pi, মানে excess path lambda by 2, where a sudden phase change of pi or excess path of lambda by 2 occurs at the point, as I have mentioned, occur at the point G when light is reflected from where? From a surface. When light is reflected from a surface backed by denser, reflected from a surface backed by denser medium, reflected from a surface backed by denser medium, but no such phase change occurs at capital N as the reflection is from rarer medium, Okay, so that is what we understand properly as the reflection is from the rarer medium. So everything is properly understood by us, that is as the reflection is from the rarer medium. So that's it. So we understand this properly. Anyway, from the theory of thin film interference, so you already know this, that the path difference between two consecutive rays is given by 2 mu t cos r. The path difference between two consecutive rays is given by 2 mu t cos r. So I will be using the fact over here. So সেটা আমরা এখানে ব্যবহার করব. So from the theory of thin film interference, from the theory of, no need to deduce, don't deduce thin film interference. From the theory of thin film interference, we know that the optical path difference, from the theory of thin film interference, we know that the optical path difference between R1 and R2, the optical path difference between R1 and R2, we know that the optical path difference between R1 and R2 will be given by what? Is delta equals to, it is, you know that it is simply 2 mu t cos r, and due to the other effects, that is the sudden phase change from denser medium, there will be some extra path, and in this case this is lambda by 2. And why this is plus sign over here, I have already mentioned that the convention that I am going to follow is the path difference is due to R2 minus R1, right? Path difference to আমি কার থেকে নিয়েছি, বড়টা minus ছোটটা, the greater one. So obviously which one is greater over here? So up to n it is same, n পর্যন্ত সেমই আছে, and after n this one is R1 and this one is R2. So definitely R2 path is lengthier. So obviously R2 যে পাথটা সেটা সাইজে বড় আছে, তাই না? The R2 path is greater in size. So that is why I need to take R2 minus R1. And this extra phase change is within whom? Extra phase change টা কার মধ্যে আছে? R1 or R2? It is definitely on R2. So that is why your R2 will be added up with some lambda by 2. And when you take this out, so this will be some R2 minus R1 plus of lambda by 2. This actually is the 2 mu t cosine of R, and then you have this plus lambda by 2. So that's it. So nothing more than this. So আর কিছু জানার নেই. So no need to show it. You may write it directly. People knows everything. Now in our case, in our arrangement, we use normal rays. In our arrangement, we use the normal rays because we want to get the fringes of equal thickness. Fringes of equal thickness means what can vary. Only what can vary. Only the thickness of the film can vary, but the angle of incidence is the same, right? In fringes of equal thickness. So here I want to fix the angle of incidence, and the different order fringes I will get due to the different thickness, right? So here the angle of incidence is fixed, and the different order fringes I actually get because of the thickness. So in our arrangement, this R is equals to 0 degree because the angle of incidence is 0 degree. Why it is 0 degree? For normal incidence. So I consider normal incidence. So if I is 0, then R must be 0 in order to satisfy the Snell's law. And this mu is over here 1. So mu is the refractive index of the medium in between. So in our case, it is ER medium. So as we are approaching with ER medium. So the medium in between the glass plate and the plano-convex lens, a plano-convex lens or glass plate er majkhane je medium ta, so that medium is nothing but the ER medium. So that is why we just follow it in this particular way. So now you may write that this delta comes out to be twice t plus lambda by 2. So it yields a very simple equation. So it yields a very simple equation. It is equation number 1. Okay. Later on I will be using mu towards the end of my class. So then you will also find that how to calculate this mu. This statement is extremely simple. So actually interference extremely, it is not at all difficult if you read it in a proper track. That is what I am trying to do in these classes. So if you read it properly with proper methodology, so then the things are not at all difficult, right? So now I will take a circular fringe. So I will show you that how to take the fringes over here. So I need to redraw the diagram once again. So আমাকে আরেকবার আঁকতে হবে, and this is very pathetic for me in order to draw the diagrams because I am not at all good in drawing all this. So once again I am in trouble. Okay, that's the idea. Okay, that would be fine. I have done a lot. খারাপ করিনি খুব একটা. Not too bad. Not too bad. This can be accepted. So this is my medium actually. এটা হচ্ছে মিডিয়ামটা আছে এখানেতে. So this is where the medium is there. The shades are the medium. refractive index. You try to draw it a bit flat, arektu flat koro mane arektu size ta lomba koro. So you try to draw this in this particular way, the things will look good, তাহলে একটু ভালো লাগবে দেখতে. Also for the diagram you may refer to your books. This is not at all good. Let me try to draw it properly. ঠিক হয়নি, বুঝেছো তো? The things is not proper exactly. Just give me 2-3 minutes, I will try to recover the situation. Actually the lens should be taken somewhere from here. Okay, now it's fine. This is my thin film. These blue dashed are the thin films. This is the same point capital N over here that I was speaking of last time. So that capital N point only, and the thickness at this point is T. Suppose the thickness at this point is T. এই পয়েন্টের thickness টা হচ্ছে T. Fine. This one is O, and you see that the where are the films produced as I have drawn in the last time. So the fringes, as you know that the fringes are circular in nature, so the first fringe will be formed over here, so then the next fringe, then the next fringe, এভাবে প্রত্যেকটা fringe হবে. So at the thickness T the fringe will be this one. So that is how the different fringes are formed. Okay, so the fringe which is formed at this T thickness, what is the radius of this? Definitely this NP, this one is the radius of that particular fringe. The fringe at this particular thickness, that is the exterior most, so that will be of this particular nature, এরকম একটা fringe হবে, and that radius will be how much? So that will be up to the end of this particular fringe, right? So that actually gives you the radius of the fringe. So NP actually gives me the radius of the particular fringe. I hope that you have understood that how the fringes are produced. So this is the fringe that is produced at the thickness T, and that is the radius of this particular fringe. তাহলে সেটা হচ্ছে এই ফ্রিঞ্জটার রেডিয়াসটা. So that is why you call it this radius, you call it to be R, and capital R is the radius of curvature of the plano-convex lens. The plano-convex lens is actually a part of this circle. So this sphere actually basically, so a sphere tar ekta part, the plano-convex lens is generated from this sphere, the radius of curvature being capital R in this particular case. So let me write over here. So here capital R is the radius of curvature of the lens. So capital R is the radius of curvature of the lens. Not here, let me write it at the bottom. So capital R, and what is this Rn? It is the radius of the nth fringe. So this one is the radius of curvature radius of curvature, বক্রতলের ব্যাসার্ধ, radius of curvature of plano convex lens. And Rn is the radius of the nth. Rn is the radius of the nth fringe. It may be bright, it may be dark, depending upon that delta and the conditions. So ঠিক আছে, so these things are well understood by us. Did I write somewhere the fringes are circular in nature? Concentric rings are obtained. ঠিক আছে. So this is from this geometry. What can I write from geometry? Let us first use the Pythagoras theorem. Pythagoras theorem যদি apply করি, if you apply the Pythagoras theorem, you see that this is xn square is equals to xp square plus pn square. Let me write it. Xn square is equals to xp square plus pn square. Now what are the different values? Xn square is capital R square. What is xp square? Xn square হয়ে গেল. What is xp square? The entire is the radius capital R, পুরোটা হচ্ছে capital R, but from capital R you just reject this thickness. পুরোটা capital R, the entire is capital R, and this much is small t, so it is capital R minus small t. So capital R minus small t whole square. And what is that pn square? Pn square is definitely it is the Rn square, small Rn, that is the radius of the nth fringe. ঠিক আছে হলো. Now this capital R square is equals to capital R square minus 2 times of RT plus T square and plus Rn square. So this one actually gets cancelled, and Tn square I neglect due to the thickness of the film. The thickness, you know, it's very small, very extremely small. It is of the order of micrometer, 10 to the power minus 6. So 10 to the power minus 6 কে যদি স্কয়ার করো তাহলে কি হবে? It will be 10 to the power minus 12. It will be smaller even. আরো ছোট হয়ে যাচ্ছে, তাই না? It becomes smaller even. So that is why you can reject this in comparison to the other terms. So whatever you have finally is that. So you have twice t comes out to be Rn square by capital R. Why do I do so? Since t square is very small. T square is very small. Film of very small thickness. So twice t comes out to be Rn square by capital R. Let us compare equation 1 and 2. So by comparing 1 and 2, what do I have is comparing 1 and 2. So if I compare 1 and 2, whatever I have is that. So I can write this Rn square by R. So Rn square by R I put on the left, and on the right I will be putting sorry compare to করা যাবে না, just I need to put the value of twice t, sorry. So delta is equals to, I shouldn't write comparing, so I should write using 2 in 1. So আমার এটা লেখা উচিত using 2 in 1. So if I use 2 in 1, so then it will have some delta is equals to twice t মানে হচ্ছে Rn square by R plus some lambda by 2. So that is what do I have at this moment, right? And this is suppose some equation 3. And now let us go for the condition of the bright and the dark fringes. So ever bright fringe dark fringe condition আমরা চলে যাব, and that will be just the completion of the treatment, and we can calculate subsidiary issues. Completion of the treatment মানে the theoretical part will be done, and then I will show you some applications of this particular Newton's ring arrangement. So for bright rings, we can say that for bright rings, whatever we can do is that for bright fringes, whatever I can do is that. So bright fringe এর জন্য আমরা কি করব? We may write delta is equals to some twice n into lambda by 2, তাই তো? For bright fringe we can write some twice n into lambda by 2. That's very fine, understandable. And then you can write this Rn square by capital R. So now what is this Rn square by capital R? So you just put the values. Bright fringe, you know, it is even multiple of lambda by 2. This is the basic condition of interference. And then you move from system to system. So this is twice n into lambda by 2. So or I may write this one to be some Rn square by capital R. This is twice n minus 1 into lambda by 2. And twice n minus 1 is definitely another integer. So we understand that it is another integer. So Rn square is equals to twice n minus 1 lambda of capital R by 2. That is what I have at this moment. And so what will be the diameter of this ring? So therefore diameter, we can write diameter square is nothing but 4 times the radius square. Right? Diameter square is 4 times the radius square, because diameter is twice Rn and you take a square. So if I multiply this with 4, so this turns out to be 2 into 2n minus 1 into lambda of capital R. Is it so? So I can write it to be some dn is proportional to what? So let me just first of all write it. So আগে এটা লিখে নিই একবার। 2 into 2n minus shift করে নেওয়া ভালো, so I must check it. Yeah, that appears to be proper. ঠিকই আছে। So I will just basically box it, so I am writing it once again. So এই জায়গাটা আমি একটা বক্স করে রাখতে চাই। I hope that this relation will be used later on. So এটা একটু পরে লাগবে। So dn square is given by this one, and you may also write that dn is proportional to what? This is very important for your exam. Show that. So dn is proportional to twice n minus 1, right? So dn is proportional to twice n minus 1. So a very important result. So this will turn out to be like this, and from here I draw a conclusion. So এখান থেকে আমরা একটা conclusion draw করতে পারি, সেটা হচ্ছে the conclusion that I draw from here is that, so the diameter of the bright ring, so the diameter of the bright rings, BR লিখলাম, হ্যাঁ, bright rings, BRS, bright rings. So the diameter of the bright rings are, so the diameter of the bright rings are proportional, very important result, are proportional to the square root, is proportional to the square root of what? Is proportional to the square root of odd natural numbers, square root of odd natural numbers. So the diameter of the bright rings are proportional to the square root of the odd natural numbers. Why do I call odd natural numbers? Because I put n equals to 1, right? If I put n equals to 1, so then it comes out to be what? So n equals to 1, but it comes out to be root over 1. If I put n equals to 2, it comes out to be root over 3, right? Proportional to odd, now this one odd, that means that is root over 1, root over 3, root over 5. If I put 3, so 6 minus 1 is 5, comma dot dot dot. So the diameter of the bright rings are proportional to the square root of odd natural numbers. Now why this is so important? So that is what you will understand once you go for the condition of the dark rings. So let me now go for the dark rings or the dark fringes. So এবার আমরা dark এর জন্য চলে যাই, for dark rings. So what happened for the dark rings? For dark rings we find that for dark rings, sorry, I should write fringes now. For dark fringes, আচ্ছা dark এর জন্য কি হবে বলো তো, what will happen? So for the dark we will have delta equals to, the condition is 2n plus 1 into lambda by 2. The path difference is odd multiple of lambda by 2. So here we can write that this comes out to be some 2t ছিল না আমাদের, this was 2t plus lambda by 2 and 2n plus 1 into some lambda by 2. So I can simply say over here that lambda by 2 তো cancel হয়ে যাচ্ছে, তাহলে আমার থাকে হচ্ছে I shouldn't write here 2n because 2t has been already replaced with rn square by r. So this is rn square by r, so I shouldn't write it that way. So I find that my rn square comes out to be over here some n lambda. So rn square comes out to be n lambda, rn square n lambda into capital R. তাহলে rn square টা এটা চলে আসে, তাহলে what will be dn square? So therefore dn square will be my dn square, তুমি জানো এটা 4 of rn square আসে, so that will be 4 times of n lambda r. So if I want to box it, so what will be your dn square? So dn square is equals to 4n lambda r. Very important result. So this is very commonly used in experiments. Experiment এটা use করা হয়. I hope that you are accustomed to this in your practical classes, maybe if you have done it, or you will be so. So this is my dn square, and the another important result that you obtained is that, so this dn is proportional to root over of n. dn is proportional to root over of n. Another interesting result that we come to know over here. So arekta interesting result যেটা আমরা পেলাম. So this actually shows that the so the diameter of the dark rings are proportional to the square root of natural numbers, not odd, square root of natural numbers, all natural numbers, square root of natural numbers, that means that square root of natural number, that means that it is root over of 1, root over of 2, root over of 3, comma dot dot dot. So that is why I said that these two results are very important. So here you see that the diameter is proportional to the odd natural numbers 1, 3, 5, and here it is proportional to all natural numbers. And let me point out this equation as equation 4, and this equation I point out as equation number 5. So একটা equation 4 আর একটা হচ্ছে equation 5. So these are the two equations that I have. Now I will go for a treatment which is called the determination of wavelength from the Newton's ring arrangement. So আমরা ওখানে wavelength বের করার চেষ্টা করব, which is also in your practical syllabus, that to calculate or to determine the wavelength by the help of this. So there is also an experimental Fresnel biprism in your course, that is also to determine the wavelength. So which we have already done, that beta equals to lambda capital D by small d. From that particular formula we have calculated the wavelength in case of a Fresnel biprism experiment. So here we will try to do so by the help of the Newton's ring arrangement. So the Newton's ring arrangement, I will show you the fringe width, so how the fringe width depends upon the orders or it is independent, and I will also show you that how to determine the wavelength or the refractive index. All this issue within the next 20 to 30 minutes. I will try to show you all these subsidiary issues. So let us go for it. So first of all, I would like to put up the heading, that is determination of wavelength from Newton's ring arrangement. One of the important application of the Newton's ring experiment. So you see that I will start from the diameter of the bright ring. So you see that the diameter of the bright ring. So what is the diameter of the bright ring or the dark ring? Anyone you can use. The diameter of nth bright ring, the diameter of nth bright ring is, by equation 3 you have, equation 4 you have it, dn square is equals to 2 into 2n minus 1 into lambda r. This is from equation 3. Okay, I get it. So this is the diameter of the nth bright ring. And similarly for n plus pth bright ring, similarly for n plus pth bright ring, what will happen? N plus pth bright ring jodi kori, so then it should be dn plus p whole square, and that one will yield over here just 2 into this one will be 2, n will be replaced by n plus p. That is, suppose I take the diameter of the 10th ring and the 15th ring. So the p value is 5 under that case. So that one corresponds to some lambda times of r. Got it? So everything is well and fine so far. And now if I just want to calculate this out, it to calculate kori, so this turns out to be some 2n minus 1. So it at 2 into 2n minus 1 lambda r. So this is a term, and then I have a 2 times of lambda r. So these are my two different terms. Oh, sorry, the second term would be, it should be 4p. So I guess, yeah, 4p lambda r. So that is what I have at this moment. So এরকম একটা কিছু আমার কাছে থাকলো. So now if I just subtract these two, so subtracting, এই দুটোকে যদি subtract করি, you understand that why did I separate out, so that will lead to some easy cancellation. So এই দুটো যদি subtract করে দিই, so then it will be some dn plus p whole square minus dn square, and this part, these two will get cancelled, and so that will simply give you some, it will be plus, so that gives you 4p times of lambda r. So 4p times of lambda r, and this actually gives you that lambda is equals to dn plus p whole square minus dn square divided by 4 times of p multiplied to capital R. So that is how you get the unknown wavelength, the wavelength of any unknown radiation. So by the help of this formula. Now the basic question that arises over here, so I also thought some long time before that this formula is capable to find the values of lambda, right? because whatever you are going to measure in this experiment is the diameter of the ring. So these are the different order rings. Suppose this is এটা একটা ring হবে, so a bright ring then a dark ring. So I just draw it by two different colors to distinguish. Suppose the red ones are my bright ring, so ধরো red গুলো হচ্ছে আমার bright ring, so I take the diameter of the reds like this. So I take the diameter of the red rings, so I can take the diameter, that is dn. I can easily calculate nth. I know the value of n, that is what I can view in my experimental arrangement আমি দেখতে পাবো আমি এটা, so I can just find it, so that's not an issue. And I can also I know the radius of curvature of the plano convex lens, so I can easily find out lambda. So knowing all these parameters, I can easily find out the lambda. So then why do we take the nth and the n plus pth ring? So that's a very interesting point. And actually in the practical vivas, these are actually asked that in the Newton's ring experiment, why do you use this type of arrangement, and that why do you calculate nth ring and the n plus pth ring, and you end up with this type of complicated formula when you can just calculate it from the this equation 3 only. I guess it is not equation 3, it is equation 4. This can be done easily from equation 4. So the reason for this is that actually in the measuring systems there can be some error. তুমি যেটা দিয়ে measure করছো, the measuring scale might have some encrypted error within this which cannot be removed normally. So সেই এরারটা আমরা নরমালি রিমুভ করতে পারছি না। So under that circumstances we need to use this type of arrangements. Why? Because whenever you measure this dn square, so this dn square you measure with some error. Actually you measure dn square with some error, because this error is present within the system, within the measuring system. তুমি যেটা দিয়ে মাপছো, the scale might not be parallel, so there can, or the scalings might not be uniform, or there are many other types of uniformity, that non-uniformity that can be present in the system. System একাধিক রকমের সমস্যা থাকতে পারে. So for that particular problems, you see that this error is present in both of these two terms. Errorটা দুটোর মধ্যেই আছে. The error is present in this one, and you see that the error is same because the measuring, the system is the same one. The diameter definitely change, diameterটা change করবে, but the measuring system, then your experimental arrangement, everything is the same. So that is why the error would be same. And now as soon as you use this formula, you see that you measure with an error. তুমি একটা error দিয়ে measure করছো, you are measuring with an error, but once you take the subtraction, you see that here is an error and here is another error. Due to the presence of the negative sign in between them, error is removed. যেহেতু এখানে নেগেটিভ সাইন আছে, তাহলে এরারটা কিন্তু রিমুভ হয়ে গেল, error is removed over here. So that is the reason that instead of using equation 4 directly, which gives you the value of that wavelength, unknown wavelength, we still prefer to have the difference of the two equations and finally calculate them out. Okay, so I hope that I have been able to make you understand, and please remember this will help you in many other experimental arrangements also. Similar type of techniques are also done in the meter bridge experiment when you take the direct current and the reverse current. So the plus E error during the direct current and the minus E error during the reverse current gets mutually cancelled. So that is what goes on. Let us repeat the same for the dark ring. So I can repeat the same, this one for the dark rings also. Suppose this is my equation number 6, suppose 6a, and let us repeat the same for the dark rings. So for dark rings, the diameter, what happened? The diameter of the nth dark ring, the diameter of the nth dark ring. So what will be the diameter of the nth dark ring? So that is given by dn square is equals to 4n lambda r. So this is as given by equation 5, right? And for n plus pth dark ring, it should be dn plus p square minus 4n plus p. N is replaced with n plus p into lambda r. Let us subtract it and you will see that you will end up with the same result. Subtracting, you will see that dn plus p square minus dn square gives you actually 4p lambda r. The n terms gets cancelled. From here you can find the unknown wavelength, or you may find the radius of curvature also. অনেক সময় radius of curvature আমরা বের করতে পারি. So that depends upon the question, that what is being asked. If r is given, you may find lambda, or if lambda is given, then you may find r. right? So that depends upon the practical question that you will get on the day of exam, but the working formula is the same, and this one you can call it to be equation number 6b, right? 6a and 6b are the same equations. You see that they are of the same form. Just you need to understand what is p. So if I call it to be the 10th ring and if I call it to be the 15th ring, so the value of p is definitely n plus p, so 10 plus 5, so the value of p is definitely 5. So eta jodi bujhte paro, if you understand this, then you are through. So then you can do the things very easily. So that's all about the calculation of the wavelength by the Newton's ring arrangement. So if you get a problem, you can easily do that. So now if you come to the determination of refractive index of a medium, determination of refractive index of a medium, excuse me, determination of refractive index of a medium, determination of refractive index of a medium using Newton's ring arrangement, using Newton's ring arrangement. So determination of refractive index of a medium using Newton's ring arrangement. So you see that already I have taken the mu to be 1. আমরা কিন্তু মিউটাকে already 1 করে রেখে দিয়েছিলাম, that is I have used the ER film, as I have said that I am using a ER film in this type of experimental arrangement. I am using ER film in this type of arrangement. So instead of ER film, if I use a refractive index type of film, so if I use the film is not ER medium but some other medium having a refractive index, so then what is the refractive index of that? So that can be determined with the help of this Newton's ring arrangement. So let us try to understand the diameter of the nth dark ring in ER film. So I write it. So now I just complete my treatment with the dark rings only. The diameter, because you are now convinced that the result is identical whether it is dark or it is bright. The diameter of the nth dark ring in ER film, the diameter of the nth dark ring in ER film. So what will be that? So that is what we have already studied. এটা আমরা করেছি, সেটা কত আছে, what is the value? So that value comes out to be, so that value comes out to be dn square is equals to 4n lambda r. Symbols having usual meaning, you will write it. And similarly for n plus pth, dark ring, what will be the case? Similarly for the n plus pth dark ring in ER film. Okay, that should be dn plus p whole square is equals to 4 n plus p lambda times of r. So dn square 4n lambda r, dn plus p whole square 4n plus p lambda r, right? So that is the situation, that is what you have at this moment. Now if you just subtract these two, the mechanism which we have been already following, subtracting just like the previous treatment, it is identical so far. dn plus p square minus dn square gives you 4p lambda r. So let us keep it with ourselves. So এটা ভালো করে রাখো, this is our equation number 1. So এটা আমাদের equation number 1 যেটা আমি পেলাম. Fine, we get it. Now if instead of ER film, you have something else. So try to understand from here. If instead of ER film, we have a film of refractive index mu. If instead of ER film, we have a film of refractive index mu in between the glass plate, and the plano-convex lens, then what will happen? If instead of ER film, we have a film of refractive index mu in between the glass plate and the plano-convex lens, so then what will happen? Then from equation 2, you recall from equation 2. So let us recall equation 2 first of all. So equation 2 te chole jao ekdom. Go back to equation 2. We need it. So you look at equation number 2, what is it? Not 2. Come back to equation number not 2. But this one, equation 1. সো ইফ দেয়ার ইজ আ রিফ্রাক্টিভ ইন্ডেক্স মিউ, তাহলে এখানে যদি রিফ্রাক্টিভ ইন্ডেক্স মিউ থাকে তাহলে এখানে একটা মিউ থাকবে, তাই তো? সো দেয়ার শুড বি আ মিউ। ইজ ইট ক্লিয়ার? দ্যাট ইজ হোয়াট ইউ আন্ডারস্ট্যান্ড। আই হোপ দ্যাট ইউ আর গেটিং ইট। ইজ ইট ক্লিয়ার? If mu is not 1, so there should be a mu over here. তাহলে এখানে একটা mu থাকবে, তাই তো? So there should be a mu. Okay? Then we can say, not from equation 2, just from equation 1 only you can say that if I don't set that mu equals to 1, if instead of air film, we have a film of refractive index mu in between the glass plate and the plano-convex lens. So then, from equation 1 only, so then from equation 1, we can say that, then from equation 1, we can say that the thickness, then we can say that the thickness T is to be multiplied, the thickness T is to be multiplied with, then the thickness T will now become, then the thickness T will now become mu T. Then the thickness T will now become mu T. Is it clear? So whatever was thickness T, so then we can say that the thickness T will now become mu T. So previously it was only the thickness that was the T, but now you see that it becomes the mu T. And this is what is the concept of optical path, which you have learned during your classes of that thin film interference. You know that this ray, so this ray particularly, these two, so these two has traveled within the medium. So এই দুটো যেহেতু মিডিয়ামে ট্রাভেল করেছিল, so that is why when you have calculated the paths, when you have calculated this path, so you have multiplied this path and this path with mu. এই দুটো পাথকে আমরা mu দিয়ে মাল্টিপ্লাই করেছিলাম and this was multiplied with 1. So I have said that in going from point P to Q, if you find that a part of the ray travels in a refractive index of mu, so then that part is to be multiplied with mu in order to get the optical path. Okay, so in order to get the optical path, so you have to multiply it with the mu. So that is what we have actually understood in our previous classes. So সেটা আমরা আগের ক্লাসগুলোতে সেই ব্যাপারটা আমাদের বোঝা আছে. So that is what we have already understood. So we can say that the thickness T will now become mu 2. So I can say, so therefore the diameter of the nth dark ring in a liquid film instead of air film, we have a film of refractive index mu. We have a liquid film. We have a liquid film of refractive index. Mu. In between the glass plate and the plano-convex lens. Then from equation 1, we can say that the thickness will now become mu T. The diameter of the nth dark ring in liquid film will be, so if I call it dn squared, so then this one I will call it some dn dashed square. So এটাকে আমি dn dashed square বলছি. So that should be, it was 4n lambda r. So 4n lambda r. So that will become 4n lambda r divided by mu. Okay. So that will become 4n lambda r by mu. So এখানে একটা mu চলে আসে. So then we can say that the thickness will be replaced by mu T and the diameter will be now replaced by this particular quantity. So diameterটা তো এরকম একটা কোয়ান্টিটি দিয়ে ডায়ামিটারটা রিপ্লেস হবে. So you may go through the details calculation of it. তুমি ডিটেইলস ক্যালকুলেশনটা এখান থেকে দেখাতে পারো. কি করে করবে? How will you show it? You just take a mu. Suppose the mu is present within the system. ধরে নাও মিউটা সিস্টেমে আছে. So if you have a mu over here, so there will be a T. So all the T's will be replaced by mu T. So এখানে একটা mu থাকবে. So there will be a mu. So now 2 and 3 you can togetherly write. So where does it go? Okay, so there will be a mu because 2t has been replaced. 2t, no, sorry, I made a mistake once again. Not here. So this is 2t rn squared, that is fine, there is no problem. So here we can say that delta equals to 2 mu t plus lambda by 2. So delta means 2 mu t. Now the replacement of 2t from here is obtained, so there will be a mu over here. So ekhane ekta mu thakbe, so there will be a mu, not here. So 2t is replaced but the mu is present, so mu ache, so there will be a mu rn square. So wherever there is a rn square, it will be a mu rn square. So mu rn square, if you just write over here all mu rn square, so sab jagay jodi ekta kore mu rn square thake, so then what will happen? So this rn square value actually comes out to be what in the last line? So this rn square value actually comes out to be mu over here. So the mu comes to the denominator. Okay, so the mu comes to the denominator basically over here. So mu to denominator, so there will be a mu on the denominator on all these terms. So that is why basically your dn square, so this dn square, so that will be mu will be in the denominator. তাহলে একটা denominator mu থাকবে। বুঝে নাও পুরোটা, I repeat once again. So there will be the thickness will become mu t. So that is why when 2t is replaced, so 2t টা replace করছি but mu will be present over here. So all the rn square now becomes mu rn square, and that is why when you find the value of rn square, যখন rn square এর ভ্যালুটা বের করছি, so that should be divided by a mu. So that is being done, it is divided by a mu. Okay, I hope that you have got it. বুঝতে পেরেছো নিশ্চয়ই? So that is divided by a mu over here. So dn square is divided by mu. Similarly, these all are divided by mu. So dn square গুলো খালি mu দিয়ে এখানে divide হয়ে যাবে. So the dn square will be divided by mu, so which I have done over here. So সেই কাজটাই আমি এখানে করার চেষ্টা করছি, which I am trying to do over here. So the diameter of the nth dark ring will be dn square and it is divided by mu. So where from do you get that divided by mu? So that is what I have explained to you in very details. Similarly for n plus pth, pth dark ring in liquid film, so that will become, so eta koto hoye jabe, so that will be again dn dashed square, but it is dn plus p now, and it is 4 times of n plus p, that is lambda r, divide mu, 4n plus p lambda r divide mu. Okay, so if I just go for subtracting once again, so what is the difference? So the difference is that the expressions are divided by mu, and where from the mu comes? The mu comes from 2 mu t. That's it. No need to show in details এ দেখানোর দরকার নেই, just I have shown you just for your understanding, because in a lifetime you must understand that where from does the mu come. So again your n terms will get cancelled and you have 4p lambda r divided by this mu. Okay, so that is what is your equation number 2. So now let us just divide this equation 1 and 2. So 1 and 2 যদি divide করে দাও, so then you will get the value of mu. So just you divide 1 and 2, or by 1 divide 2, that will be by 1 divide 2, 1 কে 2 দিয়ে divide করো, so that will give you mu equals to dn plus p square minus dn square divided by dn plus p dashed square minus dn dashed square. So that's what is the value of mu. So that is how you can find the refractive index of any unknown liquid by this formula. So এইভাবে এটা ক্যালকুলেট করা যেতে পারে. So that is the way to calculate this one, right? If you don't know the wavelength, so you may ask me, sir, that why are you not using equation 2, because this formula is used to calculate the wavelength, so why are you not using this? Mu equals to this one. But you see that if I want to calculate from equation 2, then I need to know this lambda and r. তাহলে আমাকে lambda আর r দুটোই জানতে হতো. I need to know that lambda and r, also p. But here you see that I don't need to know anything such. So এখানে সেটা আমার জানার দরকার নেই. I don't have to know anything such over here. Okay, so that is what is the advantage of the calculation of mu, that I will just look at the rings. Once the ring is formed within the air film, I measure the diameter of the 10th ring and the 15th ring. That's fine, that gives me the numerator, and then I put some liquid in between. তারপরে আমি একটা liquid put করলাম, a few drop, 1 or 2 drop of liquid in between the glass plate and the plano-convex lens. I put a liquid, and then I once again measure the definitely transparent liquid, otherwise opaque liquid the light cannot pass. So then I measure again the same 2 rings, same ring মাত্রা হবে, কিন্তু you should measure the same rings, that is the 10th ring and the 15th ring. You measure it, so that gives you the denominator. Take the ratio, you are through, done, the problem is solved. সো এইভাবে তুমি এটা করতে পারো। Next, I will go for the fringe width treatment in the Newton's ring experiment. Fringe width, as I used to do in my Fresnel biprism class, that is the division of wavefront. Then I used to do it in my class of that wedge-shaped film. I have calculated the fringe width. In both of the cases, you have seen that the fringe width is independent of the order. That is, wherever you measure the fringe, you get the same width. তুমি fringe টা যেখানেই মাপো না কেন, তোমার width টা same থাকে. So let us try to see if the same things occurs in the case of Newton's ring or not. And you will see that this is somehow different. So এখানে আমরা দেখবো এখানে কিন্তু ঘটনাটা একটু অন্যরকম আসবে. The thing will be somehow different in this particular case. So let us try to go for it. You use the bright ring or the dark ring, whatever you like. So I just use the diameter of, actually I call diameter, but it is the square of diameter. Truly speaking, it is square of diameter. So you may write square of diameter also. I am not so stringent about it. So আমি এতটাও strict কাজ করছি না। The diameter of the nth dark ring, in air film. So now I should specify what type of film I am using. So the diameter of the nth dark ring in air film. So I use the dark ring because the dark ring, the expression is a bit simple. So just এখানে এটা লিখলেই হয়ে যাচ্ছে 4n lambda r. আবার ওখানে আবার it is 2 into 2n minus 1. So it's a bit complicated to write in comparison. Similarly, for the n plus pth, dark ring in air film. So n plus pth এর জন্য করলে কি হবে? For the n plus pth, you may write it dn plus p whole square equals to 4 times of n plus p of lambda by r. Right? Nth dark ring and n plus pth dark ring, I get it over here. So not n plus pth, I'm sorry, because I am calculating the fringe width. Fringe width means the next one. For the next dark ring, so I should write for the next dark ring in air film, that is n plus 1th, that is n plus 1, that is n plus 1th, that is n plus 1th. So I shouldn't use p, but I should use 1. তাই না? Because fringe width মানে কি? Fringe width is the separation between two successive fringes. দুটো পরপর ফ্রিঞ্জের মধ্যে যে সেপারেশনটা. So let me take the difference or subtracting, and you understand that here it is squared. এখানে কিন্তু squaring আছে. So you just subtract it, you get dn plus 1 square minus dn square. So that actually gives me 4 lambda r. Use a plus b, a minus b, and I will be using an approximation over here. So dn plus 1, and this one is dn plus 1 minus dn. That comes out to be 4 times of lambda r. And from here I have this this one I call it 2 times of dn. Okay, approximately আমরা 2 times of dn নিচ্ছি because the rings are very close to each other, right? But don't say that, sir, then these will be 0. No, there is a separation, but I just approximate it. Approximately I call it. So that as I have used the approximation, so I will use the approximation symbol also. So this much sacrifice you have to do in order to get something. And it's not a bad approximation. Bad নয়. So beta, so I don't think that this will be called beta. এটাকে beta বলা যাবে না. This is not the fringe width. This is double of the fringe width. I will explain why. So let me call it dn plus 1 minus dn only. এটাই থাক এখানে 4 times of lambda r. So that basically gives me dn plus 1 minus dn is equals to 2 times of lambda r divided by dn. 2 times of lambda r divided by dn. Okay. Now what is beta? So therefore fringe width is actually defined by this way. Fringe width is actually rn plus 1, right? Fringe width টা কিন্তু dn দিয়ে হবে না. Fringe width is with respect to rn. You will understand why. So fringe width beta is actually rn plus 1 minus rn. So that means it is, if I call it with dn plus 1 minus dn divided by 2. So therefore beta comes out to be lambda r by dn. So that is the actual definition of beta. I will explain that why do I define it in terms of the radius. So you just draw the fringes over here. Suppose this is one of the bright fringe and this is another one suppose. So এই দুটো ধরো তোমার ফ্রিঞ্জ সিস্টেম আছে, লুকস অ্যাসিমেট্রিক, ভালো লাগছে না দেখতে। Let me try to draw it smaller. No. Okay, more or less it's fine. So you see that this is a fringe over here, so এটা একটা fringe and this one is the other one, আর একটা হচ্ছে তোমার the other one is something over here. So these are the two radii that you obtain, and actually fringe width মানে হচ্ছে দুটোর মধ্যে separation, the separation between the two consecutive fringes. So if I call this radius to be Rn and if I call this radius to be Rn plus 1, so one should understand that the fringe width is nothing but Rn plus 1 minus Rn. But if I just separate out the diameter in terms of the diameter, so that is the fringe width. So এবার আমি যদি diameter এর terms এ যদি করতে চাই, right? So actually now if you suppose you measure the diameter, ধরো তুমি diameter টা measure করছো। So diameter measuring means this diameter is your dn and this entire diameter, this one is your dn plus 1. So this is one is dn plus 1. So this dn plus 1 minus dn, this is not the fringe width because this actually gives which separation. So dn plus 1 means this total and dn means this one. So this actually gives me the separation, this one, this separation and also this separation. That is, I get these two separations. But fringe width is what? Fringe width is only one-sided separation. One-sided separation is defined as the fringe width. Okay, so that's why you divide it by 2. So that's the simple idea over here. So you need to get 2 দিয়ে divide করেছো. And the important issue is not this divide by 2 or not. The important issue over here is that this beta is dependent upon the diameter of the ring, and you know that the diameter of the ring again depends upon n. So diameter কিন্তু n এর উপর ডিপেন্ড করে। If it is the dark ring, this depends upon square root of natural numbers, and if it is bright rings, you know that it depends upon the odd natural number. That is, as you are going towards the outer sides, the diameter is increasing. তুমি যত বাইরের দিকে যাচ্ছ সে তো বাড়বেই, বাইরের দিকে গেলে তো রিং তো বাড়বেই। So as you are moving outside, the diameter is increasing. So as the diameter is increasing, the fringe width is basically decreasing. তাহলে fringe widthটা কিন্তু ডিক্রিজ করছে, and this is obtainable and this is visible, completely visible in the experimental arrangement. If you have seen it, it's fine. If not, so then you are, again, it's an injustice to you that you couldn't see all the features of this Newton ring. And if you have seen it, you have done the experiment, that's fine. So as you are moving towards the outer ring, you will see that the separation decreases basically. Separation টা কিন্তু আস্তে আস্তে কিন্তু কমতে থাকে। যেরকম এটা যদি প্রথম ring হয়, then this one, you suppose this is the second ring. The third ring, the separation will decrease. এখানে কিন্তু সেপারেশনটা ডিক্রিজ করবে। The separation for the third ring will decrease. Okay, right? You look at this separation and you look at this one. It is decreasing. কমে গেল কিন্তু। Look at this difference and look at this difference. Then the next ring will be something of this nature. You see, then it is further decreasing. আরো কমে যাচ্ছে, right? Then you look at this. Further decreasing. Okay, so that is, as you are moving outwards, the rings, the separation between the rings gradually decreases. That is the fringe width. You look at this beta and you look at this beta. Are these two beta same? A beta or A beta ki same? No. So this is the difference from the Fresnel biprism and the wedge shaped film. The fringe width over here is dependent upon the position where you are measuring. So this is a new observation that you find. As the order increases, the diameter of the rings increase. The diameter of the rings increase. As the order increases, the diameter of the rings increase, and hence the fringe width decreases, and hence the fringe width decreases. So this is a different observation that you find. And the final discussion in Newton's ring is the Newton's ring arrangement with transmitted rays. So finally যেটা আমরা এখানে করব সেটা হচ্ছে Newton's ring with transmitted rays. So that's the final discussion of this Newton's ring. So that is Newton's ring with transmitted rays. So Newton's ring with transmitted rays. So this is my next discussion to be followed over here. That is Newton's ring with transmitted rays. So once again, as that of the thin film arrangement, so you will see that it is complementary. So the arrangement you will see over here that it will be complementary in nature. So এখানে তুমি দেখবে যে এটা পুরো সিস্টেমটা কমপ্লিমেন্টারি হবে। So for a proper diagram you follow your book. I will try to explain from this diagram only. আমি এই ডায়াগ্রামটা থেকে এক্সপ্লেন করে দেবো। For proper diagrammatic approach you just follow your textbook. So if I complete this diagram, with a different color, say this one, so this grayish color I use over here, so you see that there will be a transmitted ray, তাহলে এখানে একটা there should be a transmitted ray over here somehow like this, একটা transmitted ray থাকবে, and there should be a reflection once again, আবার একটা reflection হবে, and then there will be again a transmitted ray, right? So these are my two rays, that is T1 and T2, and suppose I have another point over here, suppose this G, and this point suppose I call H, so এটাকে আমি H বলছি। Now in this transmitted ray you see that at G and H, both of these two rays has suffered the abrupt phase change. Now this is again a situation which you did not find earlier. So এটা আবার এমন একটা situation যেটা তুমি কিন্তু আগে দেখোনি। So previously in your transmitted system of your this parallel film system, you see that the reflected ray suffered a phase change at this particular point pi, and the transmitted ray did not suffer anything. Transmitted ray কিন্তু কিছুই suffer করেনি। The transmitted ray did not suffer anything at all. Transmitted ray, both of the transmitted ray, none of them, so this is you see only transmission, and this particular ray there are reflection, but this one is from rarer medium and this one is also from the rarer medium, because in between you have denser medium. So in the thin film experiment you have seen that the transmitted ray did not suffer any phase change. Transmitted ray কিন্তু কোনো phase change suffer করেনি। The transmitted ray did not suffer any phase change, and that is why that was a normal treatment. And here you see both of these rays suffer that phase change at the point G and also at the point H. G I have already discussed, because this medium is denser medium, so these blue dots are the rarer medium, blue is the rarer medium, and this one is the denser medium. So as the light travels from N to G, it is traveling from rarer to denser, so phase change of pi, and again it travels from G to H. So you see that this one is the denser medium, this glass, both of these are glass made, so this is glass plate and this is glass lens. So again when it travels from G to H, যখন G থেকে H এর দিকে যাচ্ছে না, তখন আবার কিন্তু H পয়েন্টে আবার ডেন্সার মিডিয়াম থেকে রিফ্লেকশন হচ্ছে। From G to H again there is a reflection from the denser medium, so আবার ডেন্সার মিডিয়াম থেকে রিফ্লেকশন কিন্তু আসছে। তাহলে কি হচ্ছে, দুবার ডেন্সার মিডিয়াম থেকে রিফ্লেকশন, so there are two reflections from the denser medium, right? So pi and pi, so you may say that either it is pi minus pi, so pi minus pi ও বলতে পারো, that is the both pi cancels with each other, and somebody argues no, I take pi plus pi, okay, then also pi plus pi gives you 2 pi, so 2 pi means again you come to the same position, 2 pi means again you come to the same position logically, right? So as there is a phase change of pi in both of them, so দুজনেই phase change আছে pi, so that is why the transmitted system will, none of them will have a extra phase change, কোনোটার মধ্যেই extra phase change থাকবে না যেটা আগের বার ছিল, and as there is no phase change, so the pattern will be just complementary, because in the reflected system there was an extra path of lambda by 2 within R2, there was an extra path of lambda by 2, but here in T1 and T2 none of them has any such, so the pattern will be complementary. So এখানে যেহেতু কোনো phase change নেই, যেটা আগের বার ছিল, last time there was a phase change, but here you don't have, so that's why. So in the Newton's ring also, in the reflected system, you must understand that the central fringe is dark in the reflected system. That is what you also should understand. So এটাও না এখানে লিখে দিতে হবে, bright ring, dark ring, so I write it somewhere. So the central fringe is dark. The central fringe is dark in that particular system. তাই তো central fringe টা dark হতে হবে, the central fringe must be dark under that condition, central fringe is dark, because normally in interference the central fringe is bright, normally interference যেটা Fresnel biprism or Lloyd's mirror, we have find that the central fringe is bright, but as there is an extra phase pi, so extra phase pi মানে কি, the system will be inverted, the system will be complementary, so that originally it is bright but it will be transferred to dark, okay? So that's it, so you have understood, and now here you may write some statements, so I have already made you understand, so বুঝিয়ে দিয়েছি, so লিখে নাও একটু, the transmitted rays ray T1 actually I said something কিছু একটা ঠিক বলি না, I didn't speak completely correctly. T1 actually did not suffer any phase change, but T2 suffers two phase changes, that is pi plus pi to pi. So T1 doesn't have any phase change. T1 এ কোনো abrupt phase change নেই because T1 is only a transmission. Okay, T1 is only a transmission, but in T2 you have two reflections. T2 তে দুটো reflection আছে, one of the reflection is at G and another reflection at H. So T2 suffers phase change pi two times. So phase change pi two times means it is originally in the same phase. দুবার phase change suffer করা মানে originally ওটা তো same phase এই আছে. So pi plus pi or pi minus pi, whatever you like to say, the transmitted ray T1 did not suffer, the transmitted ray T1 did not suffer any reflection. ও কোনো reflection ই হয়নি, did not suffer any reflection, so leave it. But T2 suffers reflection backed by denser medium, reflection backed by denser medium or from denser medium twice at G and H. দুবার হয়, একবার G তে একবার H, right? Hence তাই জন্য effectively there will be no extra phase change. Hence effectively there will be no phase change. So effectively there will be no phase change since we know pi plus pi is equals to 2 pi, right? Therefore the fringe pattern will be complementary. Therefore the fringe pattern will be complementary to the reflected system with the central fringe, because central fringe we have some interest, with the central fringe being what? With the central fringe being bright. With the central fringe being bright, right? And hence effectively there will be no phase change with the central fringe being bright. So I hope that you have understood the situation. So situation ta বোঝা গেছে that the central fringe being bright, right? So hence effectively there will be no phase change. So here I should write that pi plus pi is equal to 2 times of pi. T1 did not suffer anything and T2 suffers phase change 2 times. So pi plus pi makes it 2 pi. So everything what I need to discuss in interference of light, that has been discussed with you. So interference এ যা কিছু ডিসকাস করার ছিল সেগুলো আমরা ডিসকাস করে দিয়েছি তোমাদের সাথে. So that is what I have already discussed with you, and the remaining issues, so there is no such issues to be discussed more. Just one of the ideas that you should gather, that is the white light system. So what actually happens in a white light system? So in the white light system you will understand that the white light system, what actually happens in a white light system? So in a white light system, if the central fringe is bright, যদি এমন সিস্টেম নিলে, ধরো you take the example of Fresnel biprism, or you may take the example of Lloyd's mirror, or you may take the example of that film or Newton's ring with transmitted ray. Okay, with transmitted ray. So under these circumstances you see that the central fringe are bright, right? এই সমস্ত কেসগুলোতে সেন্ট্রাল ফ্রিঞ্জটা কিন্তু ব্রাইট হয়. সেন্ট্রাল ফ্রিঞ্জ ইজ ব্রাইট. গট দ্য আইডিয়া? সেন্ট্রাল ফ্রিঞ্জ ইজ ব্রাইট. ঠিক আছে তো? The central fringe is bright. So the central fringe is bright under this particular condition. So as the central fringe is bright for this particular condition, so you understand that that path difference comes out to be twice n into lambda by 2. So for this Fresnel biprism and the Lloyd's mirror experiment, you may just have that delta equals to twice n into lambda by 2. Now for the central fringe, you know that for central fringe you have to put n equals to 0, right? You have to put n equals to 0 for the central fringes. So as you put n equals to 0 over here, you see that your right side actually becomes 0. That is, the effect of lambda is gone. Try to understand, ভালো করে বুঝবে. As you are putting n equals to 0, এখানে যদি n এর জায়গায় যদি 0 put করো, so then the right hand side actually becomes 0. The effect of lambda is gone. So whatever be the color, violet, indigo, blue, red, whatever be the color, the effect of lambda will vanish. তাহলে ল্যামডার এফেক্ট থাকবে না, দেয়ার উইল বি নো এফেক্ট অফ ল্যামডা। সো নো এফেক্ট অফ ল্যামডা মানে দ্য সেন্ট্রাল ফ্রিঞ্জ উইল বিকাম হোয়াইট, তাহলে সেন্ট্রাল ফ্রিঞ্জটা কিন্তু হোয়াইট থাকবে, দ্য সেন্ট্রাল ফ্রিঞ্জ উইল বিকাম হোয়াইট, রাইট? সো that is why in the Fresnel biprism type of experiment, so this is the method to locate the central fringe. Central fringe locate করার জন্য এটা আমাদের দরকার পড়ে। Suppose this is your fringe system, এটা তোমার fringe system which is visible to you. Now which is the center? এখানে center কোনটা আছে বলো তো, which one is the central one? You cannot say which one is the central one, মানে এটার এই সাইড মানে এর স্কেলে করে সেন্টার এরকম হবে না, কিন্তু এদিকে আরো ফ্রিঞ্জ আছে, there are many fringe in on this side, there are many fringe on this side. So now what is the center? So in order to locate the center, people use white light in Fresnel biprism experiment suppose. So Fresnel biprism experiment এ মানুষ কি করে, white light use করে, people use white light. Now what is the purpose of that white light? So that white light will make the central fringe to be bright and white. Why white? Because there will be no effect of lambda. As you put n equals to 0 for the central fringe, the effect of lambda is gone. So lambda effect নেই মানে কি, মানে violet, indigo, blue সবাই একই রেজাল্ট দেবে, there is no effect of lambda means all the colors will give the same result. So same result, so that means all the colors are on the same point. So all the colors togetherly on the same point will again yield the white light only. So you will see that on a particular fringe it will be white. তুমি দেখবে যে একটা particular fringe এখানেতে কিন্তু white থাকবে, a particular fringe will be white in nature. So একটা particular fringe তোমার এখানটাতে a particular fringe will be of white color, right? So white color actually I cannot make it, so let me give this shade. Suppose this will be of this shade, only one fringe, একটাই খালি fringe কিন্তু এই কালারের তুমি পাবে, and on other sides you will have colored fringes, dark ও থাকবে, there will be some dark also. So when it satisfies the condition of dark fringe it will be dark, and then you will get some colored fringes. এইদিকে তুমি একটা একটু দূরে গিয়ে একটুখানি লাল পাবে, you will get some red, you will get some blue, you will get some green, right? You will get some green, you will get some orange. Okay, so এরকম তুমি colored পাবে, so you will get colored on both sides also. এই সাইডেও colored fringe তুমি পাবে, you will get colored also. Don't just concentrate on the orders of the color. I am not caring about the order, আমি অর্ডার গুলো কিন্তু দেখে শুনে আসছি না, so don't actually bother about that. I just want to show you there will be a single fringe which will be white, একটা fringe থাকবে যেটা white কালারের হবে, আর তার both sides and on the both sides you will have colored fringes and alternate dark also, মাঝখানে dark ও থাকবে, so those satisfying the dark condition, but the central fringe that will be white colored only because the effect of lambda is gone. So that is how the central fringe is located in this type of experiment. So I am not writing about it, I have made you explain. Read your textbook, everything is given in entire details, সবকিছু খুব ডিটেইলস এ বইয়ের মধ্যে দেওয়া আছে, বইটা ভালো করে পড়বে, you read it from the books. If you have any doubt or if the note is very necessary, so then you consult with me, I will provide you the notes, or I have to make it. Actually I don't have that one with me right now, so আমার কাছে সেটা নেই, so if you want it then I can provide it to you, but I urge you to go through it yourself, but নিজেরা করো, so that would be better for you. So thanks to all of you, and here I am winding up the class for today.